Hi, welcome back. We have left last day in the method of solutions. I did not start. Today I am going to start with method of solutions. Let's begin with, right? Method of solutions of linear equations in two variables. Let's have a quick look in this particular figure. Basically, the method of solution has two parts. One is graphical, other is algebraical. We have algebraic method, we have graphical method. In the graphical method, actually what preliminaries I explained you on the last day, in the last video, that itself tells you about a graphical method, right? Once you can draw the graph of the given linear equations, then you can identify those three conditions, right? Either they will be intersecting or parallel or coincidence. So whatever conditions are there, accordingly you can find the solutions. If they will be having only one point of intersection, the coordinate itself gives you the solution. If they will be parallel, there will be no solution. And if they will be coincident, then there will be infinitely many solutions. And then you cannot write a single solution for that. So simply your conclusion will be enough that it contains infinite number of solutions, right? So only this is the case where you have to write or identify specifically what particular value works as a solution for the two equations. Am I clear to you? Just go and quickly recall what are the conditions, right? That's very, very important. So I do not want to start immediately with the graphical solutions. This part I would definitely tell that you try to do as a homework. If you find any problem regarding this, then you definitely let me know about this. I'll go for this. Now let me discuss about algebraic method. Right, there are three algebraic processes by which we can solve, right, a pair of linear equations in two variables. One, it is the substitution method of substitutions, then it is eliminations, and then method of cross multiplication, right? Method of elimination, method of substitution. Okay, this S is not needed. Method of substitution, method of elimination, and method of cross multiplication. Now, one by one, we're gonna discuss everything, and then we'll take problems, and then we'll proceed for each method, right? Let's see what is the first method. Okay, before we go for the first method, this was the problem what I am supposed to do. It was left out. Let me complete these first so that you could finish the first exercise. Convert the following statements into linear equations. They are not asking you to solve it. You have to just convert this into linear equations, right? The sum of two numbers is 18 and one of them is twice the other. Listen for, you can construct a single equation for this, right? That would be the case when you did it in lower classes. Now as you're doing linear equation in two variables, definitely you will construct two equations. So here, if I need to start it formally, I should write let the numbers be x and y. According to question, what is the sum of the number? X plus y is equal to 18, right? And one is double than the other. One is double than the other. Now which will prevail, right? You will write x equal to twice y or uh, y equal to twice x. You just try to decide because both will prevail because they did not fix it, right? So listen to me. As and when you find that one number is twice the other and they did not fix anything, you fix one thing here that you have the right? You fix any one of them as the greater one, right? So I fix that x is greater y. So I can write x will be equal to twice y. So this is the situation, right? This situation is going to represent a given statement, right? So I think you are clear. Move on to the next. Okay, convert this into a statement into a linear equation. The taxi fare in a city is calculated in the following manner. There is a fixed fare for the first kilometer and the charge per kilometer of the journey, right? That is not very clear. I should have made it little clear. That means there is a charge per kilometer for the next journey, the subsequent kilometers, right? So there is a fixed fare for the first kilometer, and for each subsequent kilometer there is another fixed fare. So one person has paid rupees 290 for 20 kilometer journey, and another person has paid 440 rupees for 35 kilometer of journey. What are the corresponding equations? So first of all, you need to know what are the two quantities you do not know here. One, the fixed fare, another, the charges per subsequent kilometers, right? So let us write that. Let the fixed fare for whom? First kilometer. Fixed fare be rupees X, and the fare for its subsequent kilometer be Y, rupees Y. According to question, now just see, suppose this is the journey length, this is 20 kilometer, I am considering the first case. This is 1 kilometer and this is raised 19 kilometers, right? You must visualize like this. For this 1 kilometer, there is a fixed price, a fixed fare, that is X. And for this 19 kilometers, per kilometer you have to pay rupees Y. So that constitutes the total fare. So how much it will be? First kilometer you are paying rupees X. And how many kilometers left for completing the journey? 19 kilometers. At the rate of Y you will pay this much. And what is your total payment for the first case? 290. This is one equation. Come to the other equation, 35 kilometer journey. First kilometer you will have to pay X. How many kilometers left? 34. So 34 into Y, that gives you 440 rupees. So this is another equation. Hold for some time, try to understand the question. This is a very important question. Okay. Next. A fraction is such that when 1 is added to the numerator, then it becomes 1. And when 1 is subtracted from the numerator, it becomes half. Then you have to write the equation. Okay, first of all, just you try to imagine how does a fraction look like. A fraction will be always in this form. This is known as the numerator and this is known as the denominator. Each of you know that, right? Each of you know that. So now first of all we have to fix these two. That's the first thing you have to do. So we'll write let the numerator be X and denominator be Y. Therefore fraction is X by Y. This is what the starting part, starter you can say. Now according to question, first condition, if 1 is added to the numerator, the fraction becomes 1. My original numerator was X. I want to add to it. They did not speak anything about the denominator, means denominator remains same. This case gives you the fraction as 1. This is one of the equation. Now right at this moment only, if you want, you can simplify this and you can bring it to the simplest form or you can bring it to the standard form. So this is one equation. And what is the other condition? Other time they are saying that 1 is subtracted from the numerator. Earlier I added, this time I am subtracting. This time how much I am getting? Half. Okay. Then you reduce again to the standard form. And whatever you get, that is the required equations which is representing this situation, right? So again I would like to tell you this is a problem which is fraction problem. We haven't done the solution so far. We have noted what are the methods. Once we discuss the methods, we'll go for solving these kind of problems. But remember, before solving, this part is very important. How to construct these equations, right? Many times people do not know how to construct, and because of that they are unable to solve the problems. I'm coming now to the method of substitution. Method of substitution, that's a very important part to start with. Method of substitution. I am showing you here how to proceed in general, then we'll take the problems. These are the two equations. At the beginning you name it after putting them in the standard form. You name it. This is equation 1, this is equation 2. Now suitably make a choice of any one of these two equations. There is no hard and fast rule that you have to always start with equation 1. You can start with any one of them as per your wish, but normally it is a temptation that we start with equation 1, but that's not the case at all. But here for illustration I have done with 1 only. So I have chosen 1, and after choosing 1, what is the task? Try to understand that. You have to keep one of the variable in the left side. One term containing one variable in the left side, and the rest you have to take to the right side. For example, I have chosen this equation. Then I have taken this term and this term to the right side. And then I got a1x equal to minus of b1y and minus of c1. Then this a1 comes down. So this is what I have to do. That means after choosing one equation, you have to find one of the variable in terms of the order. Again, I would like to tell you, it's not at all necessary that you should keep the term containing x in the left side. If you'd like to keep y, that is also very good, right? So once you do this from equation 1, then this x has to be replaced in the other equation. This is done here. This is equation number 2. A2 is here. This was the place. You can see here, this was the place for x. I have brought this value here. Rest of the part remains same. Now you have to simplify. For simplifying, it's very easy. Multiply each and every term by a1 because a1 is the denominator. So once you multiply here a1, they will get cut and you'll be left out with a2, and then inside it is minus b1y minus c1. Then this will be multiplied by a1, so you'll be getting a1 b2y. This will be also multiplied by a1, so you'll be getting a1 c2. Now collect all things together which are like terms, like I'm talking about those terms having y together. So this is going to contain y. If you expand minus a2b1 minus a2b1 and then one more term containing y, that is a1 b2, we collected them together, y is taken common, the other two are kept here. And this is what, from where you will find y now. Can you now find y? For finding y, this whole thing you transfer to the right side. It will be a1 c2 minus, sorry, a2 c1 minus a1 c2 divided by, this bracket is not needed, a2 b1 plus a1 b2, right? So this is the answer. As this is a general case, you will not be able to see it very smaller because we should have values for this. But as and when you do it by problems, right, with some examples, you will find that this is a number actually. This will be a number. So this number, whatever you get, this you again put it back here in order to find what is x. That's the answer, right? That's the answer. Let's move on. Okay, we have the first problem with method of substitution. So you'll now be very clear about the complete method. So right at this moment, you see both the equations are in the same form. Like x is here, y is here, y is here. Do not see the sign after equal sign constant, after equal sign constant. If they are in the same pattern, you need not do anything. Just you mark them as equation 1 and 2. Now you have to choose either of this equation to find the value of x or y in terms of the order. As I told you, normal calculation says that we start with 1. So I'm going to start with 1. I'd like to take this y to the right side. Then I'll be getting x equal to 10 minus y. I have got this as a substitution. The name is substitution because now I have got something to put in place of x. I have got something to substitute x, right? So once you come to this, you put this value in the other equation. Remember it, not in the original equation. So you see here, this is the x, this is the place of x. I have to put here this value, that is 10 minus y, and then minus y is there, this is 16. Now this you simplify, this is 10 minus twice y equal to 16. What it gives? 16 will go that side, this will come this side. So I can write this as 6 equal to twice y, leading you y equal to 3. Leading you up to y equal to 3. So once you arrive at 3, now this particular substitution will work and it will give you x, that is 10 minus 3 giving you 7. Therefore, x equal to 7 and y equal to 3. Something is wrong. Where have I done a mistake here? Minus twice, minus 6. Minus 3, sorry, this is not 3, this is minus 3. This will be minus 3, so once it is minus 3, then this is 10 minus 3, your value is 13, right? So 13 is the value of x and minus 3 is the value of y. So what is the solution for these equations? X equal to 13 and y equal to minus 3. That's all. That's all, right? Move on to the next. Solve by the method of substitution. Again, right? Same method. Equation number 1, equation number 2. Now, what do you suggest? I should start with 1 or I should start with 2? Okay, anyone you can pick. Let me pick 1. Now, what do you suggest? Should I keep twice x in the left side or y in the left side? Let's see, keeping twice x in the left side. That means y I should take to the right side. So, what will I get? It will be 10 minus y. And what will be x equals? 10 minus y divided by 2. So, this will be the substitution. I'm going to replace this in the next equation. Okay, for a moment before I go for replacement, let me go for the another trial. Supposing that this time I do not want to take this y to the right side, I would take twice x to the right side. What will I get? 10 minus twice x. In this case, my substitution is this. Now there is a very simple question put forward to you. This substitution will be easier or this will be easier? It's very sure that both will result the same equations, same answers at the last. But my question is that when you are going to go for a substitution, which is going to give you a comfortable result, it is this one or that one. So very obviously you can choose that this is the substitution which would be more preferable because it doesn't have fractions, right? So what I mean to say is that even if you have freedom to choose any one of the equation, any one of the variable to express, but do it wisely so that you can avoid the fractions as far as possible. Always it may not be possible, but as and when it is possible, avoid it. So I do not propose you to go through this substitution. You go with this. The next immediately this you will be replacing in the other equation. Where this time you will substitute this place of y. So how will I write 3x? See here there is a minus sign, so I have to definitely block the place of y by putting a bracket beforehand only, so that there will be no problem with signs. And then this is the result. Then 3x, you break the bracket now, remove it, and then you will be gradually simplifying this. It will be giving you 5x. Take this to the right side, it is going to give you minus 14. So x is equal to minus 14 by 5. And now what will be y equals? It is 10 plus 28 by 5. then 5 will come down, it is 38 by 5. So ultimately x equal to minus 14 by 5 and y equal to 38 by 5. So this is the solution. This is the solution. Please pause the video for 1 minute, and again I'd like to request you, just check whether you are clear or not. This is 78. This is 78, and then y will be, this is 78, right? This is 78, and this is minus 14. Okay, so this is the solution. This is the solution. That's it. Now you come to the next. Solve by method of substitution. This is one, this is another equation. So now here you don't have any option because everywhere these are having some value. So you cannot avoid the fraction, right? So you take any one of the equation. I'm going to replace x from the first equation. So I'll keep twice x in the left side and 3y to the right side. I'll divide this whole thing by 2. So my substitution is ready. Where do I substitute? In the other equation, right? 3, value of x is 12 minus 3y divided by 2 and minus 4y equal to 21. Fine, great. Now we have to simplify it. So do not take tension. As I told you earlier also, let's see how in the same step we can simplify. So you see what is the denominator. Just see this. And by this denominator, multiply everything here, right? If I multiply this whole quantity by the denominator 2, so obviously they will get cut and I'll be left out only with 3 times 12 minus 3y, right? Now if I multiply this thing by the denominator 2, what will I get? Minus 8y. And in the right side it will be 2 times 42, right? Now you get the result. This is minus 36. This is going to give you minus 9y, and then this is 8y, and this is 42. So how much it is? Minus 9 minus 8 minus 17y, and then 36 you take that side, minus 6, right? Not minus 6, it is plus 6. So what is y equal to? Minus of 6 by 17. Minus of 6 by 17. Now you find what is your x. So this is 3 times minus 6 by 17, and then this is 2. Should I carry on to the calculations? I do hope that you will be able to do this particular part. Please make sure that you can understand this. Come to the next question. This should have been 4. Solve by method of substitution. Right? Okay. I wrote substitution, but there is a different trick for this problem. You observe what is the difference here. The difference must be observed because this is a very tricky problem. Normal method doesn't solve it, right? It takes a lot of time. The observation is that whatever is the coefficient of x in the first equation, that becomes the coefficient in the second equation, and whatever is the coefficient of the x in first equation, that becomes the coefficient of y in the second, and whatever is the coefficient of y in the first, that becomes the coefficient of x in the second. That should be the point of observation. So once you find this kind of things, your first step is not any substitution, is not any other method, but to add ones and then subtract ones. What happens if you do this? Just see it. If you add them up, what you'll get? 301 minus 102. This will be 9. This will be 9. 199. It will be minus 199, and then this will be minus 199y, and this will be also added. It will be minus 597, right? Minus 597, and very clearly you can see that this can be divided all by 199. 199 into 3 will give you perhaps 597. Just check it. It is 9 3 27 to 27 and 29 to 597. That means 199 can be cancelled from here, minus 199 can be cancelled from here, and from here also minus 199 and 3. So your equation is simplified. Did you understand? If the coefficients are interchanging, first you do plus and then you do the minus also. If you do the minus, they will be added now here. It will be 403. Yes, 403x, and this will be minus 403y, and this will be 403, right? 403 if I subtract it. So here directly 403 will get cut and will be left out with the simplest equation. Now just let me know whether you will be able to carry on this further or not. I do hope that you can solve this. Now all that left out is to solve these two. Not the original equations, but this one. So that is an important question because of this particular exchange of the coefficients. That's all for today. We'll be starting with the next method next day in the next video. Till then, bye bye, and try to solve some problems of the current exercise. Bye.